Professor Chomsky, shall we start?
Anytime you're ready.
Thank you. You could not wait any longer, like literally. I am truly honored to introduce Professor Noam Chomsky, widely regarded as one of the great thinkers in human history, the father of modern linguistics, and arguably the most important intellectual alive. The Chomskyan revolution placed the study of language in a psychobiological setting and played a critical role in fueling the modern reemergence of the cognitive sciences. Chomsky's scientific revolution resurrected 17th century rationalist principles and implemented them by analyzing human cognition in terms of a formally explicit computational representational theory of mind. His theory lies within the larger field of biolinguistics, the school which holds that the principles underpinning the structure of language are present in human mind and hence genetically inherited. This event has been organized by the Linguistics Association of Alama-Taba-Taba University, whose main mission is to promote and better advance the scientific study of language and raise awareness of linguistic issues with the public. We are proud to announce that the title of this talk is the Minimalist Program in 2021 with Professor Noam Chomsky, Laureate Professor of Linguistics at the University of Arizona and Institute Professor Emeritus at the Massachusetts Institute of Technology. I am also delighted to introduce Dr. David Morata, the leading and distinguished Professor of Linguistics at Alama-Taba-Taba University and permanent member of the Academy of Persian Language and Literature and the recipient of Iranian Science and Culture Hall of Fame. Please now join me in welcoming Dr. David Morata to this event. Thank you.
Professor Noam Chomsky, it's an honor for me to be in this webinar. Dear Professor Noam Chomsky, on behalf of my colleagues and our students, I'm deeply honored and extremely pleased to welcome you as our most esteemed speaker in this webinar organized by the Department of Linguistics, teaching Persian to non-native learners of Persian and ancient Iranian languages and cultures of Alama-Taba-Taba University. This university is thoroughly and exclusively specialized in humanities in Iran. It is certainly a historic moment and occasion for all of us attending this webinar, whose speaker is Professor Noam Chomsky, a genius, the great linguist of our time, an outstanding philosopher, an eminent thinker, and a passionate pacifist. In his presentation, Professor Chomsky has kindly accepted to share his current views and thoughts on the minimalist program in 2021. The cognitive revolution, which was initiated by Noam Chomsky in mid-50s of the 20th century, gained an unprecedented momentum and soon evolved as a school known as generativism, generative enterprise, biolinguistics, formal linguistics, Cartesian linguistics, and Chomskyan revolution in linguistics. Generativism as a school of linguistics embraces the main Chomskyan stream as well as a number of offshoots. Some of them were, and a number of them still are, highly influential generative models of language. Today, there are a number of non-generative, non-rationalist, namely empiricist, approaches devoted to the science of language. But firstly, following the generative, or more specifically the Chomskyan paradigm, and Chomsky's initiative, they all search for universals of language, though, of course, within their own philosophical orientation. And secondly, they define themselves and their approaches by comparing them with generative grammar's approach philosophically, theoretically, methodologically, and empirically. Chomsky's approach is also remarkably distinct from other rival approaches in today's linguistics in that he claims that sometime maybe 60,000 years ago, language was there in its modern form without further changes. In fact, the effects of having a complex symbolic system are barely there before 60,000 to 100,000 years ago. Chomsky adds, the simplest assumption, we have no reason to doubt it, is that what happened is that we got merged. You got an operation that enables you to take mental objects or concepts of some sort already constructed and make bigger mental objects out of them. That's merge. As soon as you have that, you have an infinite variety of hierarchically structured expressions and thoughts available to you. Professor Noam Chomsky, we are eagerly waiting to listen to your talk and learn about the state of the art in the minimalist program in 2021. I've been notified that Professor Chomsky will address our webinar for about 40 minutes. Then I will have 20 minutes for questions and comments, if I may. Thank you very much, Professor Chomsky. We are eager to listen to your presentation.
Thank you very much. It's a great privilege personally to be able to be with you today, even if only virtually. I'm particularly pleased because of the fine work that's being done in the areas that interest me at your university and at the University of Kurdistan. Excellent, outstanding investigations. So an extra reason to be very pleased to be with you today. Well, let's begin by asking the first question. What is language? There are various approaches to this. There is a traditional view that holds that the core property of language is that it is the source of our thoughts. In modern terms, that would mean that the language generates thoughts roughly in this manner in which your some internal system coded in your brain generates all possible arithmetical properties, multiplication table, for example. Then you can access them in one way or another. Same idea, the language generates thoughts. One way or another, you can access them in what you and I are now doing, producing them, internalizing them when you hear them. There's a second view, very modern view, which holds that the core property of language is that it's an instrument of communication, a more complicated version of animal communication systems, radically different from the traditional view, which of course recognizes that language is used for communication, as are many other things we do, but that has no counterpart in the rest of the animal world. I should start off by saying that the traditional view seems to me on the right track. There's mounting evidence that in fact language is fundamentally structured as a system of thought with its uses for communication, telling jokes, whatever else you do with it, as kind of a side property, ancillary property. This, I should say, is entirely compatible with modern evolutionary biology. Been made clear. First of all, it's obvious from looking at the content, but it's also it's not a commonplace, commonly accepted by leading evolutionary biologists like Nobel laureates in evolutionary biology, Salvador Luria and François Jacob, to mention just two. Well, let me try to spell out the basis for these conclusions, which I think essentially support the traditional view that language is the source of thought, and in modern terms, a system for generating thoughts. So let's begin by asking, what are thoughts? There are views on this topic by leading thinkers. Alan Turing, one of the founders of the modern theory of computation, the founder of artificial intelligence, author of a famous paper which initiated the field called Can Machines Think? And he says in the paper that the question whether machines can think, is too meaningless to deserve discussion, because we have no independent concept of thought. Right at about the same time, Wittgenstein, whose seminars Turing was in fact attending, in his aphoristic style, said about this that humans think, maybe dolls and spirits. His way of saying, the way we use the term thinking, we apply it to something that humans do. And since words have a kind of open texture, they're free to be used in somewhat metaphoric ways. We can extend the usage to things that we conceive of as being like us in certain respects. But it's not a factual question whether dogs think. It's a question of choice, like whether airplanes fly. Some languages yes, some languages no. But there's no substantive issue. So thinking is something that humans do. We can try to characterize it. Turing himself said, as far as he knows, thinking is just some kind of buzzing in the head. Well, we can do better than that by now. We can spell out some of the properties of what the buzzing in the head is, at least for that component of thought that is formulated in human language, the one component of thought that we have any clear grasp of. Let me make clear that the thought generated by human language is not inner speech. Inner speech is different phenomena. The actual thought that's going on is inaccessible to us by introspection, just as inaccessible as the workings of our second major neurological system. There's another brain, the enteric nervous system, huge nervous system, sometimes called the gut brain. It works to keep the body functioning. We can study it from the outside. We can't introspect into what it's doing. And actually the workings of the first brain, this one, are about the same. We can't introspect into it. Inner speech is telling us something quite different. I'll return to that. Well, let's begin by looking at some of the quite surprising, remarkable properties of language. Some of these were recognized at the origins of the modern scientific revolution in the 17th century. Galileo, his contemporaries, created a fundamental new scientific revolution, mainly by willing to be puzzled. Their predecessors, neo-scholastic philosophers and scientists, had a fairly rich descriptive science, but it was descriptive. They had answers, but the answers to questions, but the answers didn't mean much. So why does a rock fall and steam rise? Because they're moving to their natural place, things like that. Galileo and his contemporaries were not satisfied. They were puzzled by the question, why does a rock fall? Why does it fall at a certain rate? And so on. And that's the origin of the modern scientific revolution. The willingness to be puzzled about ordinary phenomena is a talent that should be cultivated. Little children have it, worth keeping all your life. Well, language did not escape their attention. Galileo and other contemporaries were amazed and awed by what they saw as a most astonishing fact, that with a few symbols, our minds can construct infinitely many thoughts and can even convey to others who have no access to our minds the inner workings of our thinking. This they regard it as one of the most astonishing phenomena of nature. Galileo himself described the invention of the alphabet, which gives a way of recording this, as the most stupendous invention in human history. Well, I think their amazement was very much on target, very much correct. We should be amazed by this phenomenon, seek to understand it. And there were efforts in the years that followed, what were called general and rational grammar, to try to explicate at least some aspects of this mystery. It's called general grammar because they were hoping that it would apply to all languages. Rational grammar because it was seeking explanations, not just descriptions of phenomena. Well, this continued into the 19th century. Later was swept aside by structuralist, behaviorist currents, didn't have these interests, and it was forgotten, revived in the 20th century. Come back to that in a moment. These same concerns are a large factor of what led René Descartes to establish his famous dualist conception of the nature of the world. There's two substances, one matter, body, physical, the material world. A second one, res cogitans, the thinking substance, which has quite different properties, cannot be absorbed within the mechanical world. And a key part of the reason for the res cogitans was exactly the property of language that I just described, sometimes called the creative aspect of language use, the capacity which all normal people have to construct in the mind infinite number of thoughts and to produce them on occasions in a way which is appropriate to circumstances, but not caused by circumstances. As the Cartesians put it, we may be incited and inclined to speak in certain ways, but we're not impelled. This element of freedom of choice for appropriate use is something unique. It's a unique property, he felt, unique to humans, which is associated with the ability to construct this infinite number of thoughts in our mind. Well, Isaac Newton followed shortly after, and he basically demolished the theory, but we should understand how. He had nothing to say about mind. He thought Descartes' theory of mind looked quite sound. What he destroyed was the theory of body. He showed there are no physical objects that have the character assumed by the founders of modern science, what was called the mechanical philosophy, mechanical objects, kind of like the complex artifacts that highly talented, skilled artisans were producing all over Europe at the time. World is just a bigger artifact of that kind. Newton showed that cannot be true. Means there's no mind-body problem in the traditional sense, and not because there's anything wrong with the mind, but because there's no body. All we can do is try to construct the best theories that we can, whatever entities they postulate. That's all we can say about what's real. John Locke, shortly after Newton's Principia came out, within a few years, drew the obvious conclusion, known in the history of philosophy as Locke's hypothesis, that thinking is just a property of some organized component of matter. That's all we can say about it. That was then studied extensively through the 18th century, and as far as early Darwin. Then it too was forgotten completely, rediscovered in the late 20th century as what's sometimes called an astonishing hypothesis, a radical new idea in the philosophy of mind and in the neurosciences, namely the idea that thinking is a property of some organized system in the brain. Basically what the standard view of the 18th century repeated now in almost the same words. Well, there's another traditional idea that had never really taken fire, but has to be rediscovered. That's Aristotle's distinction between possession of knowledge and use of knowledge, generation versus production. In modern terms, competence and performance. That was almost totally forgotten. All the years, the millennia that followed, there were studies of performance, use of knowledge, but not of competence, possession of knowledge. It was revived with the modern theory of computation, Turing, other great mathematicians, which made a sharp distinction between the internal program that generates an infinite set and whatever you do to access that. Generative grammar essentially followed from the modern theory of computation, the theory of generation and competence associated with various ideas about how the knowledge you have is used. Well, assuming Locke's hypothesis, language is based on organized structures in the brain, we then proceed to ask, how do we develop theories of this? And there are theories at two levels. One of them has to do with the faculty of language itself. We want to know, what is that faculty? Apparently a species property, common to all humans, apart from severe pathology, and it seems unique to humans. There doesn't seem to be any analog in the rest of the animal world. That's one reason, incidentally, why it's hard to study. So take human vision. We know quite a lot about it, about the basic neuroscience, that's the neurology that lies behind it. We know this because of experimental work with similar animals, cats and monkeys. Rightly or wrongly, we have allowed ourselves to do invasive experimentation on these animals, which has determined with great refinement how even the individual neurons in the visual system respond to various kinds of visual stimuli. What happens if you deprive a kitten of structured patterns in early infancy, and many other things. And since humans have essentially the same visual system, we know a lot about human vision. Can't do that with language. There's no other animal to investigate. So investigation has to be much more skilled, roundabout, looking from the outside. But there is a great deal that you can learn in this way. That's one level of theory, the theory of the faculty of language. Today it's often called UG, Universal Grammar, new sense of a traditional term. There's a second level of explanation, that's particular languages. I would like to know lots of questions about what are the properties of Tagalog, Swahili, Farsi, whatever you're looking at. Well, an explanatory theory of a language is, in fact, a generative grammar, a recursive procedure for generating the structures of the language, their interpreters, the thought that they express, and the ways in which they can be externalized into usually sound, but could be some other medium. In fact, the medium that you use to externalize what's internal to you is sort of like a printer that's used by your laptop. Your laptop can have a program, say for arithmetic multiplication, doesn't care what printer you use. And language seems to be rather similar. The internal program generates thoughts. You can use speech, you can use vision, sign languages, virtually identical with spoken language in its internal nature. You can even use touch, because any sensory modality, just as the computer can use any printer. So we have two levels of explanation. One, try to construct the best generative grammar for each particular language. And at a deeper level, study UG, try to find the theory of the faculty of language. Well, as soon as we do that, we run into a problem. If we are regarding language as a trait of humans, that is an organic property, has to meet the theory, UG, has to meet several conditions. One condition is learnability. The theory has to account for how an infant, from scattered evidence, can attain the knowledge that it possesses. Second condition is evolvability. UG had to evolve. How did that happen? Third problem is universality. Has to be common to all languages, despite their apparent extreme variety. That's a conundrum. These conditions seem to conflict with one another. For learnability, the theory has to be rich enough to make the leap from very restricted evidence to very rich knowledge. And very quickly, we now know that by 2 or 3 years old, long before a child is producing anything very much, it's already mastered remarkable properties of its language. Experimental work has shown that. Statistical studies of what's available to the child have now shown that the input is extremely limited. So you have, on the one hand, you have to assume a theory rich enough to account for this tremendous gap. You look at evolvability, you draw the opposite conclusion. There's pretty good evidence now that the human language evolved pretty much along with humans. It's roughly 200,000 or 300,000 years ago. Before that, there's no significant evidence in the archaeological record of any serious symbolic activity. We now know from genomic studies that humans began to separate at least 150,000 years ago, and they share the same language faculty. That's not long after humans appear on Earth, roughly 200,000 to 300,000 years ago. In evolutionary time, these are instance, flicks of an eye. So it seems that something happened, some small rewiring of the brain, which pretty much along with modern humans gave rise to our language faculty. Now that implies that it should be very simple, that we have a conflict. Learnability suggests should be very rich. Evolvability suggests should be very simple and limited. And in the background lurks this problem of universality. Now, these are the kinds of problems that have sort of shaped the study of the theory of the generative enterprise, the theory of the nature of language. They've become much sharper in recent years because of the recent discoveries that I've just mentioned. So turns out within the minimalist program in the last few years, there are ways arising that seem to offer a solution to the conundrum. I'll talk about them now. Let's begin by looking at what it is that a 2 or 3-year-old knows. Some of these things are pretty remarkable. Now, been demonstrated that by 30 months old, maybe even earlier, infants already know the fundamental principle of what's called structure dependence. A remarkable and surprising fact about language. The operations of language do not pay any attention to the linear order of words or other surface structural arrangements. They only operate on abstract structures. We see that in very simple examples. So suppose just take ordinary conjunction. 2 boys and a girl are hurting themselves. Why don't we say 2 boys and a girl is hurting herself? That's a very simple computation. It says that the copula B will agree with the closest noun adjacent to it. So 2 boys and a girl should say is, not are. But we don't do that. We say are, not is. You see the same in slightly more complicated cases. So suppose I say the man who fixed the car carefully packed his tools. Ambiguous. Could mean fixed the car carefully packed his tools. Suppose you put carefully in the front. Carefully, the man who fixed the car packed his tools. No ambiguity. It just means fixed his tools. That means that carefully does not find the noun, the verb phrase that's closest to it, but looks for the more remote one, the one farther away. Not fix the car, but pack the tools. Every infant knows this. As I say, 30 months. And it's quite astonishing when you think about it. It means the child, the infant, is ignoring 100% of what it hears, which is all linear order. It's not using cognitive processes that are well within its cognitive repertoire, like picking the next red bead on a string, say, easy. Not using any of those. What the child is attending to is things it never hears, but that its mind constructs, structures in the mind. And this happens to be universal for all languages. Well, obviously unlearnable. There's no evidence for it. It must be innate, must be part of our fundamental nature, part of UG, and we have to ask ourselves what it is. That's a deep problem of language, for which we now have an answer. Why is there order altogether? Why do we string words out one after the other? Well, that's not a property of language. That's a property of the sensory motor system, the printer. The articulatory organs just can't produce structures. They can only produce things one after another. So the printer is if you like, defective. It doesn't work well for language, but that's what we have. Actually, sign language uses slightly richer properties because visual space offers other options. But these are basically not the linear order structure arrangements are really not basically properties of language. They're properties of an amalgam of language and some sensory motor system which has no relation to language. Existed long before language appeared and hasn't changed since language arrived. Well, that gives us a way to look at one of the parts of the conundrum, the apparent variation of languages. It seems the more we investigate that the surface variety of languages does not have to do with the inner system that's generating thoughts. It has to do with the externalization to a sensory motor medium. That seems to be the locus of variety, mutability, complexity. So that's not really part of core language. It's part of the association of language with external systems that have nothing to do with language. We look back to the internal language itself, the thought-generating system. I can't prove this yet, but it's more and more looks like it's the case that it's virtually uniform among humans. It's just part of our nature. Well, going back to the explanation for structure dependence, notice that the problem of learnability doesn't arise. The problem of variety doesn't arise. The only problem is evolvability. So what we want to show is that structure dependence could have easily evolved within the conditions of human evolution. And in fact, there's an answer to that. Structure dependence follows automatically from the simplest computational procedure, one which has to exist for an infinite generative system to exist at all. Technically, binary set formation, what's called merge in modern usage. Well, no problem of evolvability, no problem of learnability, no problem of variety. We have an explanation for one of the most fundamental, most surprising properties of human language. That's the perfect result, perfect explanation. First time in the history of the long, rich study of language that there have been any true explanations. Well, let's look a little further. We look at merge, the simplest computational operation. It's evident at once that there's basically two kinds. The two elements that are merged can be distinct from one another, or one can be part of the other. That's called external and internal merge. And both apply in the formation of sentences. So if I say, John read the book, putting the pieces together by external merge. Instead of the book, I could have put which book. John read which book. But then you have the option, and some languages you do it, others not, of taking the phrase which book, which is part of the thing you've generated, and merging it with the whole thing, internal merge. Then you get which book, John read which book. Notice you don't lose the original which book. The ear doesn't hear it because efficiency conditions in externalization say, don't bother pronouncing everything, just pronounce the least you can. But the internal system receives it. And that shows up very quickly in understanding of sentences. So if I say, the boys expect the girls to like each other, it means the girls like each other. Words like each other, so-called anaphors, find the closest antecedent. So the girls, not the boys. I suppose I say, which girls do the boys expect to like each other? Each other doesn't find the closest antecedent. Which the boys. It finds the remote antecedent, which girls. It's the girls you're expecting to like each other, even though you don't pronounce it. The point is that what the brain is seeing is which girls the boys expect which girls to like each other. What the ear is hearing is which girls the boys expect to like each other. But the brain doesn't pay any attention to that. It's looking at what's internally generated. That we can't introspect into that, but we have evidence for it, like what I just mentioned, and tons more. Well, that's a famous property of language. It's called displacement with reconstruction. Linguists will recognize this. It's always been considered a major problem. Why does language bother with the displacement? What are these complicated rules of reconstruction? When you look at it from the point of view of the minimalist program, there's no problem. The brain is simply hearing the sentence with which girls in the position of the closest antecedent, and the internal merge just comes free. It's the simplest operation, in fact, involves the least computation. So all of this is exactly what you expect. Displacement and reconstruction are not a problem. We have a perfect solution to them. Going back to inner speech, notice that inner speech is not inner. When you say the sentence to yourself, you use the externalized form, not the internal form. So what we call inner speech is just a pale reflection of outer speech, where you don't activate the articulatory gestures. It's not an interesting phenomenon. It tells you nothing about thought. That's a big misunderstanding in modern philosophy. Well, gaps, like the kind I mentioned, are not always copies. Let's take another case. Suppose you said here, many books were stolen from the library. That means there are thieves around. Suppose you say, many books are easy to steal from the library. Totally different meaning. Doesn't mean many thieves or many thieves are around. You're talking about some specific books, maybe biographies. So there is a gap after many books. The sentence again, many books are easy to steal. There's a gap after steal, but it's not a copy of many books. They have a different interpretation. There's interesting explanations of this, which I don't have time to go into. Notice also that there are different kinds of thoughts. So, for example, if I say, he arrived at the hospital and he arrived at the hospital in a taxi and in a coma, that's fine. Suppose I say, he arrived at the hospital in a taxi and a coma. That's impossible. Classical rhetoric, it's called zeugma. The point is there are different kinds of events, different kinds of thoughts. There are compound thoughts and there are individual thoughts, all expressed in coordination. Well, a lot more to say about this. We have by now good explanations for that, again, in terms of genuine explanations that satisfy both learnability and evolvability. I'll just end by going back again to the 17th century, bearing in mind the crucial distinction between generation and production, Aristotle's distinction. Look back again at the Galilean challenge, Cartesian challenge. Parts of it we're beginning to know how to deal with. What are the mechanisms that permit this astonishing ability? Some things we don't know how to deal with. How can we, in fact, produce expression, externalize, develop thoughts which are appropriate to situations, not caused by them, and even convey them to others. Creative aspect of language use, that remains a mystery. And I just end by quoting David Hume's reflections on Newton's discoveries, long study of Newton. He writes that Newton's greatest achievement was that while he seemed to draw the veil from some of the mysteries of nature, he showed at the same time the imperfections of mechanical science, and he thereby restored nature's ultimate secrets to that obscurity in which they ever did, and ever talking about whether they ever will remain in that obscurity, we don't know, but they certainly are in it right now. So major progress in some areas, old traditional problems still deeply recalcitrant, conceivably beyond the reach of human intelligence. I'll stop with that.
Thank you very much, Professor Chomsky. I would like to mention that more than 5,000 individuals have attended this webinar in Iran. Thank you for your insightful review of the main issues which have preoccupied linguists' attention since mid-50s of the 20th century up to the present time. If I may, I have 3 questions to raise. My first question is that in your article, Beyond Explanatory Adequacy, and in another article, 3 Factors in Language Design, you talk about genetic endowment, linguistic experience, and principles which are not specific to the language faculty, namely principles of data analysis, principle of structural architecture, and developmental constraints, and principle of efficient computation. In Beyond Explanatory Adequacy, you deal with extra-linguistic and external principles as well as interface conditions. My question is that with these modifications and that, as you mentioned in On Phases, that beyond explanatory adequacy is a deeper level of explanation, then is the minimalist program a truly Cartesian model of language anymore?
Well, first, these papers that you're talking about are about 15 years ago. There's been a lot of progress since then. I think we can formulate the matter much more clearly now. But with regard to the Cartesian conception, I remember that Descartes himself said almost nothing about language. His followers, people greatly influenced by him, like the Port Royal grammar, which I was in fact quoting from before, which was a mixture of Cartesian and Pascalian influences. They went into this in great depth and developed rich conceptions about what language might be like. They did not deal with Descartes' problem, the problem of creative aspect of language use, the basis for the mind-body bifurcation. And that remains as mysterious now as it was then. In fact, that's true of voluntary action generally. But the mechanisms that are involved in it, they had some ideas we can do much better today. And I think going back to the nature of your question, of the various things that you mentioned, that enter maybe the interfaces. The one that has proved really productive is computational efficiency. The others factors have told us very little. But computational efficiency, we can think of as just a property of nature. It's natural law. Nature works in certain ways independent of language. One of the ways it works is by trying to keep things as simple as possible. And nobody really knows why, but that's the core of science. Galileo put it simply. He said, nature is simple, and it's the task of the scientist to show that. That's been the credo of science for the last 500 years. And there's lots of reflection among great scientists as to why this is the case, but you just take it for granted. That's science is the study of the simplicity of nature. And in fact, simplicity is closely related to explanation. The simpler your theory, the deeper the explanations. So this drive for simplicity is in part an aspect of the nature of explanation. In part, it's an assumption about the nature of the world, the universe. The Galilean assumption that nature is simple, we have to find out how nature does it. Well, these principles of computational efficiency do fall within that. So as far as the study of language is concerned, you kind of just take them off the shelf. They're there for the taking. They're not part of language. They're part of the natural world. And just like physicists and chemists and others, just take them off the shelf when they're needed. And that has been very effective. You can account practically everything I just said relies on, crucially, on notions of computational efficiency. The simplest possible computational operation, merge, is the one that yields the deepest explanations. The gap when you hear is because the computational system is trying to be efficient. So it produces things that don't give you direct access to what you're thinking. In fact, that turns out to be a big problem for natural language processing. But language doesn't care about processing and communication. It's hard to understand, too bad. We're just trying to make things perfect. Actually, that even shows up in such elementary examples as coordination, the one I started with. So suppose you, instead of using and, use or. You say two boys or a girl, then what's the copula? Is in the room? No, can't say that. Are in the room? Can't say that. In fact, you can't say anything. There's no way of expressing the thought. But language doesn't care. It's perfectly happy to make things incomprehensible because language is following the laws of nature and is just trying to be as simple as possible. And the simplest rule is say, don't look at order, look at structure. And that happens to yield something you can't even say. It's a fine thought, but there's no way of saying it. Well, dramatic example of how the nature of language simply doesn't care about communication or any other use. It just developed to be perfect. So, and the other, I don't have time to explain it, but the things about compound versus singular events, slight difference, also follows just from efficiency of computation, from that anaphora, many others. The things about the different kinds of the different kinds of gaps, all of that follows from minimal computation, which happens to make communication difficult, but gives you all of these properties of language. I think that's about the best we can say now. And the task for the future is press the limits of efficient computation to see how much of language you can explain, how much of it is due to some extraneous circumstances, how much of it just follows from this change that took place in human evolution at some point, which yielded the capacity for infinite generation using the simplest possible computational operation, merge. How much follows from that? How much from other developments in human evolutionary history? I think that's pretty much where we stand now.
Thank you very much. Professor Chomsky, with respect to merge, you have made it very clear that external merge is used basically to give you argument structure. Internal merge is basically used to give you discourse-related information, like focus, topic, new information, all that kind of stuff that relates to the discourse situation. Today, you also talked about displacement and restructure. As done, they are done by internal merge. Now, my question is that taking into consideration the very valuable notion of merge, which consists of two portions, external and internal. Now, what comes out of this computation would be a syntactico-pragmatic unit, not necessarily a purely formal object, because part of the information will be pure morphological, lexical, and syntactic and semantic information, and part of that will be discourse-related information. So the outcome is not anymore a purely syntactic object. I would like to call it a syntactico-pragmatic object. Also, I think in line with this discussion or assumption, I can say, if we find linguistic elements in the syntactic core part of language, and also find its counterpart with exactly the same phonetic and phonological form, the same item, the same element, doing an information task in the language. I personally do not feel that interface would be sufficient to handle these cases. And I have a good number of them in my studies on Persian and a number of modern Iranian languages spoken in Iran. Now, I'm inclined to talk about a kind of interdependence. I believe in modularity of language. I do adhere to modularity. And at the same time, I do think that based on what I have been able to understand from my data, that there is a great deal of interdependence between the modules of language: syntax, information structure, morphology, syntax, and other modules as well. Now, how would you view your reaction to such a modeling of language?
Well, let's go back. First of all, let's be clear about terms. Syntax in the traditional usage just means symbolic manipulation, something that's going on inside. Now, going back to Aristotle, that's possession of knowledge. The syntax is the possession of knowledge. It's the symbolic manipulations going on inside the mind, which yield all of the possible thoughts, and in fact, yield the basis for articulation or signs for sign language. So phonetics and phonology are syntax. They're formal manipulations inside the mind which feed information, which the articulators or the hands access to make events in the outside world. That's production of knowledge based on possession of knowledge. Now, as far as the distinction you brought up properly between the two kinds, the uses of external and internal merge, it's called duality of semantics, it's commonly called. There are, just as a matter of fact, with no knowledge of how it's used, two kinds of merge. You can put things together which are separate, or you can take one that's inside the other and add it to it. That's all Mother Nature knows. There's two kinds of merge. Actually, if you look at the two of them, internal merge, this one is much simpler. External merge means finding two things that you've produced anywhere, all over the so-called workspace, huge search, picking them, putting them together. Internal merge says, no, I only have to look at this one, and I find something inside and put it there. Much simpler operation. So the real question is, why does language ever use external merge? The answer is what you said. Internal merge can't give you argument structure. And doesn't give you subject-predicate relation, for example. So you need external merge for that. Well, you look at the way Mother Nature operates. You have both internal merge and external merge. Now we have other cognitive faculties. Language is not our only cognitive faculty. So we have the faculty of articulation, for example, physical articulation, moving the articulators. At the other aspect of language, we have operations of reflection, inference, and so on. These external cognitive systems access the language. The language is pure syntax, all the way down to phonetics, all the way up to formal semantics. It's all syntax, internal. But other cognitive systems access this system, and they try to do it in an efficient way. So the other cognitive systems see, I'm putting this anthropomorphically just for ease of description. The other cognitive systems see that language has two kinds of merge. So it says, okay, I'll use them systematically. One of them I'll use for argument structure. The other I'll use for discourse structure. That's the way the external systems in their use of knowledge use the knowledge, internal syntactic knowledge efficiently. I think that's what we find. So there's really no interaction. The internal system just grinds away, doesn't care how it's being used. The other cognitive systems want to use this system in an efficient way, so they distinguish, want to use one just for argument structure. You could have been different. You could make up a system in which internal merge gives argument structure, but it's much more inconvenient. So the way it's used is you just take the basic so-called thematic structure, subject, agent, patient, goal, and so on, do those with external merge. And then you have the simpler operation, internal merge. We'll use that for discourse-related properties like information structure and so on. That seems pretty much the way language works.
Professor Chomsky, thank you very much. My third last question, if you don't mind, would be that as for the typological literature, I would appreciate if Professor Chomsky could express his opinion about whether those findings in the typological literature might positively guide the research within formal linguistics. As an example, Walpiri, a native Australian language, reported in 1978, as early as 1978, to have an ergative absolutive system in terms of case marking, also called by typologists flagging, whereas in agreement system, its agreement system, also called indexation cross-referencing by typologists, is nominative accusative. I have also shown in my research that Northern Talishi and Northwestern Iranian language, the case system is ergative absolutive type, but its indexation cross-referencing agreement is, or agreement system, is tripartite, as typologists say. So the case system, namely flagging, goes one way, and the indexation system goes another way. Now, when we go back to the generative linguistics literature, we had in the principles and parameters theory era, we had a split IP hypothesis. We divided IP into tense and agreement. In some books, the authors postulated 3 syntactic nodes for agreement in English: subject, direct object, and indirect object. Then suddenly agreement disappeared, and it was analyzed as being part of case system with the probe-goal relation to account for this dependency. Later on, Mark Baker revived, I would say, the agreement node. I think he worked with a native speaker of Kurdish and came to the conclusion that looking at agreement is inevitable. In my research on modern Iranian languages, I have noted that the strongest mechanism in all Iranian languages spoken in Iran is agreement, indexation, whether they have a split ergative system or you have a uniform nominative accusative system. Now, I wonder if we listen to some of the findings of the typological literature, then they might weaken, in my sense, still the dominant notion of average standard European in theory construction and theory modeling. I think a lot of time and energy can be saved if we also listen to the findings of typologists, I would say. I appreciate your assessment of what I said, my understanding of what I said, and I will certainly benefit from your comments.
Well, as you say, the study of ergative and accusative languages within generative grammar goes back 50 years, 1970s. A lot of it was, in fact, initiated by the study of Basque. The 1970s, Slavic Basque languages have become very intensively studied, and Australian languages was mainly work of the late Ken Hale, colleague and friend at MIT, who the languages that you mentioned, like Wellebury, were the languages that he investigated. It looked at the time in the 1970s as if this was a fundamental split in several types of languages. In fact, the way this is described is in terms of parameters. You have an option for one kind of language or another kind of language. So in English, you have the head, the verb, the preposition, the noun precede its complement. You say, read the book. In Japanese, it's the opposite. Book, read, room, in, and so on. So it was thought, well, two different kinds of languages. It was even thought, Ken Hale's the one who proposed this, early 70s, that there's a free word order parameter. Some languages have free word order. Others, like English, have a lot of structure. There's been a lot of work since then, very important work, which has increasingly shown that these systems are fundamentally the same. Take Wellebury, the most extreme free word order language. Ken Hale and his student, Julie Legate, worked out, discovered, mostly Julie's work, it's her dissertation, that Wellebury actually has the same structures as English. It's just that you don't see them. They show up in the way sentences are interpreted. They're part of the internal system. So Wellebury, the most extreme free word or language, seems to have the same structural relations as you find in the strict structured languages like English. And with regard to the case systems, it's a very interesting topic. This, I think by now, I think at least, it's pretty clear that you don't want these agreement elements. They're what are called the agra elements. You do it simpler with minimal search. There's very good work now. I can't go into it by some of it by Julie Legate, the same person. Another study just coming out, will be in print soon, by Giuseppe Longobardi, Italian linguist, now in England at York. A very extensive study of hundreds of languages and their case systems, and a uniform theory with very few minor parameters distinguishing them. So I think maybe it's intensive work, very interesting work. It includes the Iranian languages, and the kind of work that you're doing contributes enormously to this. May find unitary systems with deeper principles and very small changes on the outside that seem to give these divergences. I think it's a very rich topic and being intensively studied. The most extensive work I know is by Legate and Longobardi, along somewhat different lines, but with very broad typological coverage. And in fact, I should just say that this is something very common in the sciences, not just linguistics. You go back, say, to the 1950s, it was generally assumed that languages can differ in almost every possible way. That was called the Boasian thesis. It was in fact articulated in those terms. Languages can differ in almost any possible way. When you study an individual language, you have to do it without preconceptions, because language variation is so enormous. Same thing was believed in biology, that organisms were so different, because you look at them, they're all totally different from one another, and they vary in so many possible ways that each one has to be studied on its own evolutionary history, its own properties, nothing more you can say about them. With regard to biology, it's been shown to be totally false. By now, it's discovered that there are deep conservation properties that go back hundreds of thousands of years in some cases, that determine the possible kinds of organisms, which are very restricted. It's gone so far that there have even been proposals that there might be a universal genome, one basic genome for all complex organisms with minor variations. And I think the study of language is going in the same direction. Things that looked very different. If you don't understand something very well, it looks extremely complex. All you can do is kind of record the data. The more you get to understand it, the more you see that there are deeper underlying principles that restrict the kinds of possibilities there are. Well, the minimalist thesis takes a strong position on this. It's a thesis, not demonstrated. Hypothesis. It says the thesis is that how close can we come to showing that all of the properties of language are reducible to fundamental natural laws and simple operations of the kind that are basically parts of nature, like minimal search and so on. How much of language can we explain in terms of that with minor variations on the surface in the externalization system, determining whether the language goes this way or that way. Now, these parameters, the options, have to be learnable. They also have to be learnable. Even if they're all in the externalization system, the child has to acquire them. There's by now very good work on how they can be acquired simply. Ian Roberts, a fine linguist in Cambridge, England, has a recent book in which he covers literally thousands of languages and shows that with a very simple cognitive processes, very simple ones, there's a path through them which enables the child to very quickly pick the right parameters for the limited data that it's getting. It's another rich area of study. David Lightfoot, also British linguist, has a recent book which looks at this from a complementary point of view. So these are all very live areas of study, I think, which you bring up is very important. Typological studies, just as descriptive studies in biology, seem at first to give you an enormous range of possibilities. The closer you look at them, the more you begin to understand, the more you see that there's deep conservation, that they're basically cast to the same mold at a deeper level. And the basic goal of science is to see how far you can go with this.
Thank you very much, Professor Chomsky. I do 100% agree with you that beyond the variations that we find in the data, there are a few systems, regularities at work that explain all those superficially variant appearances. I have tangibly felt that kind of regularity in my studies on Iranian languages. But at the same time, I have not been able to convince myself that, for instance, parameter setting can account for the kind of mixture in word order of all Iranian languages, past and present. Iranian languages are, in terms of word order typology, constituent order typology, are mixed in terms of VO and OV parameters, 24 parameters. And that is the case since 5 centuries BC. I can't say that there is a change in progress. How long does it take for a change to replace another situation, another type? So these are questions that have preoccupied my attention, and I search everywhere and certainly look at the minimalist program literature to find answers for these questions. Dear Professor Noam Chomsky, I do not have your picture anymore. I hope you can hear my voice. I would like to say to you, up to this moment, 7,000 listeners attended this webinar. So I'm very thankful to you. I should say that I'm personally very much scientifically indebted to you. I cherish great memories from every line of your brilliant writings. On behalf of my colleagues and our students in Allame Tabatabai University, I sincerely thank you for the valuable time you spent today to share your expertise and knowledge with us. Good luck and best wishes to you and all people who participated in this great and memorable event. Thank you very much.
We don't have, please tell him that we can't hear him.
I'm sorry, we couldn't hear you. I mean, sorry.
You disconnected the microphone. He has disconnected.
I think you may have disconnected the microphone. That's what my colleagues here say.
How's this?
Now we hear you. Now we hear you. Good.
My wife is my technician. Technological system.
Okay.
She's, yes, I just want to say it.
Greetings to your wife for her wonderful book on psycholinguistics.
Yes. In fact,
Yeah.
maybe I can entice her to come here, but she doesn't like to be on camera.
Okay.
She's in the background making things work. Okay, it's really been a great privilege. I've been delighted to be with you. I'm very happy to see the kind of work you're doing, which is a major contribution to the field. And I hope we'll have soon, when lots of political nonsense is overcome, we'll be able to work much more closely together. As you know, we have a strong Iranian language program here at the University of Arizona, where I am, Simin Karimi. But I hope there'll be close cooperation in the future.
Thank you very much. Thank you very much. I appreciate the time, energy, and sharing your vast knowledge with us.
Thank you.
It's another event. Goodbye.